A quick look at the signal operator. Before we begin, just between us, we have to internally change the name signal to pulse. Think of a pulse as a short burst. A signal is the kid in caboodle with extras. I didn't come up with the name signal, but pulse is the more correct term. I will still use the term signal throughout this text as not to be confusing, up until I show you why it's important that we internally switch. Allow me to remind us what signals are. It is a complex variable, meaning an object with properties and methods, similar to how arrays have a length property and a push method that allows you to add stuff to them. And an array is a complex variable, an object that is efficiently programmed for the purpose of storing things like numbers, letters, and other complex objects. Unlike an array, which does not announce any changes, a signal, when given a non-null value, will immediately notify all of its subscribers. A subscriber is just a function that is given the value of the signal during the notification. It only gets one argument, just the pure old value of the signal. Let us make a signal, and we will call it username. Const usernameSignal equals new signal. Look at the code I circled in the title image and follow along. This is a null signal because we didn't specify a value. Even so, we will now subscribe to it. usernameSignal.subscribe v sent to console log with the argument v. I use the letter v, but you can use the word username, though you can see that it is redundant because we are in the usernameSignal subscription. That's why I only use v. In a horrible mistake, some people give the signal dependencies so that you can log v and some other signal, and that second signal will be remembered as a dependency. And now, whenever it or the username changes, the subscription will be reran and printed to the console. Don't do that. Do not make the signal more than a value holder with some simple checks. It's supposed to notify its subscribers on non-null value changes and nothing more. Last week, I was fool enough to tweak the non-null comparator. I foolishly provided a customized isNull function. But with just such a tiny change, you could no longer check if a value was simply null. Now you had to run the .test and then use the dot value. Ew. Old school hackers, I believe, call it obliviate. You must protect the simplicity of signals. They are far too precious, especially in context of user interfaces, something that is outside of JavaScript or ECMAScript design considerations. We need an extra layer to tame the user interface. This simple signal can't do much more than notify all of its subscribers when the value is non-null and it actually changes. But that gives you power, because your mind is good at simple things, and now you can strategize without added complexity. So we will make a mapFunction, and this will be a signal utility, also called an operator, and it should be both external, where you can say map usernameSignal mapFunction, but also be good to yourself and create it internally within the signal, where you just give it map method and it will call that reusable map function with the this keyword as the first argument and the given map function as the second. Mapping just allows us to transform information, and in the case of signal, transform information, but only when that information is available and has actually changed. You can imagine how we want to prevent unnecessary changes to complex user interfaces. So if there was no change, nothing should re-render on your screen. The map method that belongs to the signal object should return the result of the map function. We're just wrapping one with the other. The keyword this, by the way, is how objects refer to themselves internally. So inside the username signal, we don't say user signal, because when a programmer creates a signal, we have no clue what variables they will be using. So we need a special keyword, and that's the keyword this. And as a quick side note, the difference between function and method is that functions are just straight-up programming language features. Methods, however, are functions that belong to an object and can use the keyword this. That means that they are basically in something that looks similar to another function, so they are nested things. You can think of objects as a grouping mechanism for functions. If you want to call another method of an object that you are in, you have to prefix the call with this dot and then the method name. But again, methods are just functions that are inside an object. The signal extension, or the act of adding the map method, is where the naming problem reveals itself. Our perfect little signal must be renamed to pulse. You will often find yourself using just the pulses without any of the added extras. The extension that has that fancy map function will now be referred to as signal. So externally, no one will notice the change, but you will know that if you don't need anything extra, you can just straight up use the pulse. Such is the world of programming. Map takes two arguments, a signal to map and a function to send the value of that signal through. So a map transforms or maps the value of the original signal and then returns a new signal that delivers that transformation. The way this is accomplished without ruining anything, remember, pulses and signals are precious, is by creating a new signal called mapped signal, subscribing to the given signal, in this case username signal, and taking that V out of the username signal and passing it through the map function, and then jamming the result into the mapped signal value. If you just look at the screenshot, all of this makes sense. It's very important and very nice that when you call the map of a signal, you just get another signal. This uniformity helps you reason, helps to keep code clean, and it prevents most of the surprises. And yes, you are not returning a pulse, you are returning a signal, so it also has a map method. You can map that too. Now let me give you the short version. Map returns a new signal, the mapped signal. It is a standard signal, as we have it here, that subscribes to the signal that was fed into the mapped function, so it's monitoring it. And then each time the original signal changes, that new value is passed through the map function and assigned to the mapped signal. So we create a chain. It does not get much more complicated than this. This was the shot, and it did not hurt. There are a few more interesting tidbits and a bunch of operators. Just like the function of an object becomes a method under the object theory, a function that operates on signals also has a special name. That name is operator. So map is an operator, and there are many operators. You can look up reactive programming operators, but please don't let their documentation scare you. To understand an operator, you have to understand its code, like we are doing here internally. It is almost always very simple, and in our case, we just pass the original signal value through the map function, often referred to as predicate, and return the result. So this whole map operator is just a single function call. There are entire pages written about the map operator and what it does and how it should work. Please don't bother with them. Finally, just to summarize, our map function predicate is where we can add stuff to our username. Not signals, but some text like hello. We can now say usernameSignal.value equals Alice, and then follow up with usernameSignal.map v sent to string template hello v subscribe console log, and we will see hello Alice in the console. Don't be scared of the syntax. Just look at the image provided. That's just about the worst of it. Those bad ticks, they mark a string template, and the $sign with curly brackets is how you allow values into the string. You get used to it. It's actually really cool. If you want to go through the trouble of installing Node.js and then execute this file, you will see hello Alice in the console. As to the exact flow control, the map function automatically subscribes to the username signal, because that's the point. We want to map the value of the username signal, so we will subscribe to it. But now that it holds the value Alice, it will instantly execute the subscription. This is like an initialize feature. This means that it sends the value Alice to the map subscriber, which then sends the v through the mapped signal function predicate, so the tiny little function that's provided to the map operator. Then the result function is just assigned to the value of the mapped signal, which is what map returns, right? It's that uniform feature where using an operator on a signal will just return another signal for predictability and uniformity, for symmetry. And now we have a value assigned to the mapped signal, and that means the subscriber to the mapped signal, which in our case is just console log, will be executed immediately. And that prints hello Alice. So the first signal is just sent through the map function and assigned as value to the second signal that you are monitoring and sending to the console. It's not complexity that you hear. It's just that English sounds weird when you are describing program flow. But that's okay, because looking at the tiny snippet I provided undoes all the tangled words. Code is your friend. It explains everything. It's more visual than people think. Learning that signals are tiny and precious, and then understanding that you can use an operator on them, and that the operator will transform the original value, but also return a signal that you can chain in some other way, is a huge deal. It's incredible. The provided source code also reveals a beautiful thing about signals, because debounce, delay, and throttle each accept a millisecond value. Using signals allows you to optimize your program so that it only runs at a reasonable speed without thrashing the user interface or without running slow on single-board computers. It's a rare feature and very precious. Signals are the future. They are just the perfect abstraction over the user interface, a perfect extension of the JavaScript language. And get this, they are also compatible with visual programming languages. And this being the future, artificial intelligence can help you snap them together. And if you want an extra bonus, you can buy Android smartphones marketed as game consoles with controllers on each side, and then create a visual programming language that helps you play the user interface. Signals may sound complex when you hear of them first, but then they turn all the complexity of handling events and user interface needs into a simple visual challenge of managing connections and using operators to transform data.